to another video here. This one I'm going to just show you guys real quick in case you missed it in class how to add a custom material to your onshape document, which we're going to need for the Imagine the Future activity. So of course the first thing is to get logged into onshape. And I'm going to start by creating a document, and I'm just going to name this one real quick, assigning custom materials. And when I get into my workspace, what I'm going to do is quickly just drum up a rectangular prism, just for the sake of demonstration. Obviously, whatever you're creating for this activity is going to be different. So give this some 3D appearance. So I have a little cube here. And just like assigning a regular material out of the material library, I'm going to start by right-clicking on my part, going to Assign Material. And when I load this up, it's going to default me into the Onshape material library, which of course then I could, if I needed to, I could pick out a material, common material, right? However, as you guys know from the activity, these are not common materials. So what if I need to add something like titanium foam? Well, what I would do is I would go over to this custom tab. And here, I would type in the name of my material, so titanium foam, and all of these are blank. So the density does default to 1 kilogram per meter cubed. That's obviously going to be different depending on the depending on the material that you are using. And then I have all these things: Poisson's ratio, Young's modulus, tensile yield strength, ultimate tensile strength, compressive yield strength, and ultimate compressive strength. I'm not going to go into details on what all of these are, though. Young's modulus we have seen before. These ones we're going to kind of get into in the Principles of Engineering class. And then this one comes up every now and again, and it's basically just kind of states how material deforms under compression. So, well, what I need to do now is go out and find as many of these figures as I can. All of the materials you should be able to find a density for. Most of the materials you can find most of these other things. So Young's modulus is a very common one, tensile yield strength is a common one, ultimate tensile strength, and then compressive yield strength and ultimate compressive strength are typically for materials that are subjected to a compressive load. Not all of these will be, so you might not find things like this, but as long as we're at least finding the density, we're going to be okay. So you might be asking, well, how do I do that? Where can I find this, right? And for that, we're going to have to, again, do a little bit of research. So if I go to Google and I look up, for instance, titanium foam material properties, we can see that I've already done this for a class. I can search that. And yes, I do get a AI overview. I kind of want to skip over that because a lot of times it does not give me exactly what I need. Sponsored results, I would also suggest skipping over because these guys pay to have their results first, and we can see that these are people trying to sell us on something, so we don't need, right? I see this in stock. I see this titanium foam manufacturer. So these guys pay to get their spot there. So I can go ahead and scroll down, and I can find something maybe by American Elements, which I know has at least one of my figures that I need. But maybe I'll go down here and see. Sometimes you have to click on a couple of things and try to find the information that you're looking for. So I can see here I have a yield strength, and this gives me with some type of porosity. So I have 60 megapascals in compression, bending, and tension. And then I have a stiffness value too. So I can actually use this stuff, okay? If you don't know what this means, you can search it up, but let's pay attention to the units here. 60 MPa. MPa, large MPa, is a megapascal. Mega means million. And so I need to pay attention to that when I put that in here. And so if I look at this, it says let's see, yield strength in compression. Well, that's going to be my compressive yield strength. And that's, again, 60, not 60 pascals like I have here. I got to pay attention to the unit. That's going to be 60 million. So 60 with 1, 2, 3, 4, 5, 6 zeros afterward. I also have tension, 60 megapascals in tension. Well, that will be my tensile yield strength, 60, 1, 2, 3, 4, 5, 6. That is 60 million pascals. And I have stiffness values vary with the testing method from 7 to 14 GPa. And that's not your grade point average. That is your gigapascals, okay? So that's 7 to 14 billion pascals. I'm going to split the difference here, kind of go with the average, right? 7 plus 14 is 21, divided by 2 is 10 and a half. So I'm going to say that and I know that's my Young's modulus, is 10 and a half billion. So I need a bunch of zeros. I'm going to need 1, 2, 3, 4, 5, 6, 7, 8 zeros after. That gives me 10 billion 500 million pascals. And then the density, the only other thing I can really find here, these other ones I can leave blank for now. The bell just rang, so I'm going to have to get back to work. The density, I know from a previous document here, and so this shows you that sometimes I have to go floating around. I can click on one of these data sheets. I'll just use the most pure one that they have. And when I download that, I have a data sheet, and I get the density as 4.54 grams per cubic centimeter. So when I enter that in here, I have to pay attention again. I have kilograms per cubic meter. So I'm taking this number and multiplying it by 1,000. So that's going to get me 4,540. 4,540. And at this point, I have enough information. It's okay if you have a couple of holes here. It doesn't matter that these are blank. Again, some of them you're going to be able to find this. Some of them you won't. But if you get this much, that's good. I can hit check, and now this is titanium foam. And when I hit display mass and section properties, if I click on my shape, it gives me a weight. It gives me a volume. I'm all good here. All right, I hope that this video helps you get the assignment done. That's how you assign a custom material.